In this video, we're going to look at finding the derivative of an inverse of a function. Sometimes we may not know the actual formula for the inverse equation, and sometimes we may not even have the function equation, but we should still be able to find the derivative of the inverse either way. So in example 1, they do give us an equation, f of x equals x cubed plus x. Generally, when you would find the inverse, you would flip x and y. So the inverse of this equation would be x equals y cubed plus y. This is not an equation that can actually be solved for y. So we can't just solve for y and then find the derivative of the inverse that way. So we need to be able to find the derivative of the inverse whether or not we can actually find the equation for the inverse in terms of y. And so the way we're going to do that is we're going to use the identity that if you take the function and you put the inverse inside the function, so if you do a composition of a function and its inverse, those are going to cancel each other out and you're going to be left with just x. That's the definition of inverse, that the function and the inverse composed together cancel out to just x. So we're going to take the derivative of both sides of this equation. So the way we do that is we put a d dx in front of both sides of the equation. D over dx means find the derivative. So it's very simple to find the derivative of x. The derivative of x is just 1. And to find the derivative of a composition, we need to use the chain rule. So we'll start with the outside function. The outside function is the f. Well, we know that the derivative of f is f prime. Keep the inside because it's chain rule, so we're going to keep the inverse in the inside. And then chain rule says take the derivative of the inside. Well, we don't know what the derivative of the inverse is, so we're just going to use d over dx. D over dx represents derivative, so this, and just put inverse right after it. So that means derivative of the inverse. And that's actually what we're trying to solve for. That's what we're trying to find, the derivative of the inverse. So if I want to find that, all I need to do is divide this extra stuff over to the other side. So the formula, and this is a formula that you'll need to memorize, the formula for the derivative of an inverse, so derivative of an inverse, is 1 over the derivative at the inverse. That is the general formula of an inverse, derivative of an inverse. So how does this apply to the function we've been given? So the function we've been given, f of x, equals x cubed plus 1, and we want to find the derivative of the inverse. So we're going to find the derivative of f of x. The derivative of f of x is 3x squared plus 1. So this notation up here says take the inverse function, f inverse of x, and plug it into the derivative function. So we're going to plug this in where we see x. So in this case, the derivative of the inverse is going to be 1 over 3 times the inverse squared plus 1. Running out of room there. Okay, so how do we really use that formula? Generally, they're going to have us find the derivative of an inverse at a point. So let's do this at x equals 2. So if I want to find the derivative, d over dx, of the inverse at x equals 2, I'm going to plug a 2 in here for x. So what I really need to know is where does the inverse equal to? What I need to know is what is the inverse value at 2? So if you think back to inverses, again, inverses you switch x and y. The inverse at 2 is the same thing as asking, where does the original function equal to? So I really want to know, where does x cubed plus x equal to? Now, this is not an equation you could solve by hand, so in this case, you'd have to go to the calculator. So if we just graph this, x cubed plus x, and so the question is, where does this equal to? We may be able to find that in the table, so if we do Control T, yeah, it's right here in the table. You can see right here at x equals 1, y is 2. So x cubed plus x equals 2 when x equals 1. So that means f inverse of 2 equals 1. So we're going to use this inverse formula that we just solved over here. So we're going to plug in f inverse of 2. So we know that f inverse of 2 is just 1. So in this formula here, we have f inverse of 2 squared plus 1. So we can replace f inverse of 2 with 1. So we have 1 over 3 times 1 squared plus 1, so that's just 1 over 4. And we can do the same thing at x equals 0. Let me just erase my x equals 2 work here. So we want to find out the same thing. Where does the inverse equal 0? And we can again do that with the calculator. Or where does the original function equal 0, sorry. What is the inverse at 0 is the same thing as asking when does the original function equal 0. And again, if you look at my table, you can see that the original function equals 0 when x is 0. So now I'm trying to find the derivative of the inverse at 0. So I'm going to plug in 1 over 3 times f inverse at 0 squared plus 1. And we just saw that f inverse of 0 is 0. So I have 3 times 0 squared plus 1, which is just 1 over 1, which is 1. Okay, so again, in general, the general rule for derivative of an inverse function is 1 over the derivative of f at f inverse. So you try example 2. It's just like the example we just tried. Pause the video, take a few minutes, try this problem, unpause the video, and the answer will appear. Okay, so for this example, you should have gotten 1/12. Now, the next example involves a table problem, and typically this is what the derivative of an inverse question generally looks like on the AP exam. They don't actually give you a function. They give you a table of values, and they'll give you, it'll have to have at least an x column, an f column, and an f prime column. So example 1 says, suppose f of x is invertible, that just means it has an inverse, and differentiable, means it has a derivative. Use the table to find the derivative of the inverse of f at x equals 3. So again, we know we want to find the derivative of f inverse at 3. And that's going to be equal to 1 over f inverse, or f prime at f inverse of 3. So the first thing you need to do is just figure out what is f inverse of 3. And so again, the way we do that is we figure out where does f of x equal 3. So we come up to the table, where does f of x equal 3 at x equals 2? So f inverse of 3 is 2. So we're going to plug that into our derivative formula. So we now have 1 over f inverse at 2. And f inverse at 2 is something we can very easily read off the table. At 2, f inverse is negative 4. So we have 1 over negative 4, which is just negative 1/4. So you try the next two. Again, pause the video. When you're done, unpause the video, and the answers will appear. Okay, here are the answers for 2 and 3. If you have questions, bring them to class.